Hello, welcome to this video on simultaneous equations where we look at three variables. Now this will be a little advanced for some students because it's not in every exam, so check if it's going to be in your exam where you need to do it. Although I do encourage learning for the sake of learning, and this is something that will reinforce your other simultaneous equations. It will reinforce the substitution method that I teach to do simultaneous equations. If you're unsure, look at the last video. So today we will do this example here. Now I'd like you guys to maybe pause it so you can try it yourself. I won't rewrite this, too much work. I'll just use this here. 1, 2, 3. These are just numbers for it. You don't need to write this really. This is just to help teach. Okay, I know there's an algorithm that will solve this. You match up some of the equations, add them together, get two simultaneous equations, two variable simultaneous equations. Use this another algorithm for that, and you're done. But again, I would like to teach substitution method. It will work every time for every type of equation, for every type of simultaneous equation, and multiple situations in maths. I just think it teaches more reasonable maths thinking. If you want to use the algorithm though, that's fine. I'm not your boss, but I will teach this way. Okay, so I look through here and I find one equation, any one I want. Well, let me first say, I guess, with three equations, I cannot solve any one of them on their own. They all have three unknowns. That's too much. I need one unknown. So 3 is definitely too much. So what I have to do, I have to think about this. I find one equation and I get x equals, or y equals, or z equals. I use that information and I put it into the other two. So you'll see what I mean now, hopefully. And again, pause it with that bit of idea, give it a go. Or at any point pause it when you think, oh, I think I know what he means now. I'll try it. No, I didn't. Come back to the video. Okay, so I'll get the third one here. I just have some notes because it is a long question. In case I go wrong, I don't want to waste my own time. You don't have that. You don't have that ability in exam. So really, at the end of the question, you just have to test whether you're right. Okay, so I'll use the third one, and I'll get x equals, because there's an x sitting right there. X equals 7. I'll take 3y from both sides. Destroy this, create this. I'll take 2z from both sides. Destroy that and create that. Okay, and we'll call this equation 4. I'll try and keep things a little to the left here. Now, this information can be put into 1 and 2. So I can write 1 again, and it becomes 3 multiplied by x. But not just x. X is now 7 minus 3y minus 2z. Minus 2z. So everywhere I see an x, I will just put this whole line. I know that seems horrible, but it does this amazing thing that we'll see in a moment. 2 plus 5y minus z equals minus 3. So we'll call that equation 5. Sorry, no, we won't call that equation 5. So this amazing thing now, this only has 2 unknowns. We had 3, now we only have 2. 2 is much easier than 3. But I can clean this up. And now let's go a little faster, since this is more advanced topic. Let's get all the y's together. This is minus 9y. Minus 9y. I'm sorry, I meant to do this a little faster. Minus 9y plus 5y is minus 4y. All the z's, we have minus 6y, minus 7. Minus 7z, I'm sorry, minus 7z. All the numbers, we have 21 equals minus 3. Take away another 21, I'll get minus 24. Okay, that agrees with what I had. I'll give that an equation, 5. We got all of this from 1. So let's see what we can get from number 2. Number 2 will tell me, let's go even faster this time. two x's. Let's do it all together here. Let's go 14 2 sevens. Minus 6y, 2 times this. Minus 4z, 2 times that. But we're still here. We're still writing number 2 out. Plus y minus 3z equals minus 9. Again, let's clean all this up. All the y's together, we get minus 5y. All the z's, we get minus 7z. And the numbers, let's take 14 from both sides. We get minus 23. Oh, lots of minuses in this. Yes, that is what I got on paper as well. What have we got? We call this equation 6. Okay, so now I could finish the video, really. I could say to you, well, here's a simultaneous equation. This is what we did in the last video. It's no different. But I'll continue on anyway, because I would like to point out just one little thing at the end. But really it's going to be identical to the last video. You could write these two out again and put them on top of each other if that makes you feel better. But it's not really that important. I think I should have room here. Let's pick which one. They both look nasty. Does 7 go into anything? 4 will divide in, not the both of them. Nah, it's going to be nasty no matter what I do. So let's just pick y from equation 5. Let's just get y equals minus 24 plus 7z divided by minus 4. So make sure you're aware of what I did there. I said y is equal, I added 7z to both sides, destroyed this, created this. I then divided both sides by minus 4, destroyed this one, created this one. So you should be able to do it quite quickly as you move on. Although there's too many minuses. I don't like leaving a minus in the bottom row. You can if you want, it's just, it doesn't look that great. Doesn't divide into both of them. So I'll just go 24 minus 7z over 4. That's y equals 7z. So this is an equation. Let's see, what we call this 6. Right, 7. Call it 7. Right, so we used 5 to get this. Let's write 6 out now. So it's a bit messy here. Minus 5. And I'm going to write y. Minus 7z equals 23. Minus 23. Let me check if I'm still correct with everything. Unfortunately I used a different equation. So I'm just going to have to continue and hope I'm correct. So 24 minus 7z. Because if you do this in different orders, here I used 5 to get something. If I had to use 6 to get it, I should still get the same answer, but my numbers will be different until the end. Okay, so let's multiply this out. Let's multiply everybody by 4 and multiply this one by 5. Let's do it in parts though. Minus 5 multiplied by 24 minus 7z minus 28z is equal to minus 92. And let's get all the z's together then. So what have we got? We have 35 plus 35 minus 28, so that's 7 z's, is equal to, let's see, we have let's write it out because it's going to get a bit messy. 92 plus, so this is minus 120. Add 120 to both sides. 120. What is that? That's 28, isn't it? So z is equal to 28 divided by 7, which is equal to 4. Let me make sure that is what I got last time. Okay, I did. Perfect. Did it a different way than I did on paper, but I got the same answer. Phew. But we're not finished. So many students finish now. They just say, oh, z equals 4. Might be lucky if that's all you wanted, but no, the question nearly always asks, find x, y, and z. So I need to find x and y. Look around. Luckily enough, here is an equation with y equals. Boom, I want y. So let's get it. 7 tells me, I might run out of a bit of room here. Y, well no, I should fit it. You know what, I know this is further from the camera, so I'll write it a bit bigger. Y is equal to 24 minus 7. Oh, instead of z, I know z is 4. So 7 multiplied by 4 divided by 4. This is equal to, well, there's multiple ways I can do it. 4 divides to 4 and this gets 8. So it's 8 minus 7 is 1. Or I could have just multiplied it out. 24 minus 28 is 24 minus 20. Well, wait a minute. 4 does not go in 8 times, does it? It goes in 6 times. I was thinking 24 is smaller than 28, so we get minus 1. Let me check. Good, that agrees with my answer as well. Y is equal to minus 1. So this would have been 24 minus 28, which is minus 4, divided by 4. But I divided in first, but it goes into both of them. Okay, so now all I need is x. I look around, and equation 4 tells me what x is equal. It tells me x is equal to 7 minus 3y plus 3. So minus 3, 1. Minus as 2z is minus 8. So x is equal to 2. Let me see. Okay, perfect. Not quite finished. Although I am finished. I've got the full answer, everything I need. I put your answers together. Good habit to do. I didn't do it last video. X equals 2. Y is equal minus 1. Z is equal 4. Put a little box around it. If you are doing an exam, help the examiner out. They'll like you more for it. If an examiner likes you, they'll work harder for you. They'll look for answers. They should look anyway, but they are human too. So help them out. Make them like you. Okay, when you're finished, this is not for the examiner, this is for you. If you have time in the exam, which you often do, maybe you don't. Maybe just put a little star beside it, which means, okay, I need to come back here and check this. End of your exam, you'll probably have 20-30 minutes left if the exam is timed correctly, because maths, we like to make sure you have lots of time. Come back and check the answer. X is equal to 2, y minus 1, z equals 4. I won't do them all now, but well, maybe we'll just do a couple. What have we got? 2 minus 1 and 4. Okay, so we got 6 minus 5 is 1. 1 minus 4 is minus 3. Correct. Yeah, let's do them all. We have 4 minus 1 is 3. Minus 12 is minus 9. Correct. We have 2 minus 3, which is minus 1. And minus 1 plus 8 is minus 1 plus 8. Yeah, is 7. Correct. Excellent. We have the right answer. Okay, so this substitution method will work for so many things in maths. It's a great way to think about things. Get x equals, that becomes a whole new option for x. It allows you in a way to get rid of x, to destroy it in some ways, to think of it. Very useful, very powerful. Thank you for watching. If you have any questions, please leave some comments below. And I'll see you in the next video. Bye.